Hello. This is a bit of a strange video, but yeah, this is a video about this thing right here. What is this? It's a bunch of masking tape and bits of paper, but this is a special one, geometrically. This is for you mathematics nerds, or topology, or geometry. It's more non-Euclidean geometry, but whatever. So this is one part non-Euclidean geometry. I'm just gonna put it there. Non-Euclidean geometry is... Okay, let me explain Euclidean geometry. Euclidean geometry is sorry, my cat wants to come in. Right. Hello. No, stay with me. So non-Euclidean geometry. Euclidean geometry. No, stay with me. Okay. Euclidean geometry, is geometry that is on a plane, like not like an actual plane, but like a flat surface. So, for example, cubes are perfectly shaped and look completely fine on a plane. So right here, so it's completely flat. Then you have the cube, and all the other faces are also flat. And so basically, non-Euclidean geometry is the opposite of that. Non-Euclidean geometry is where planes aren't completely flat. So this is a non-Euclidean plane. What type of non-Euclidean plane? It is a let me remember the word. I forgot. If anyone has good memory, you can post it in there, and is also a geometry nerd. So this is technically supposed to be flat, but kind of is not, right? So if we were in a this is hyperbolic. This is a hyperbolic plane. Okay, so if we were in a hyperbolic plane, this would be flat. So yeah, so this is a hyperbolic plane, and right there is the center, and it has 5 pieces of small bits of paper, which are square. These square bits of paper are smashed together with masking tape, and on a normal plane it would be 4 squares or triangles or whatever, and they would make a tessellation, but this tessellation goes up a bit, so that's why there's 5, and then it's basically I'm adding an extra square where there should not be to make a Euclidean plane, but this is not a Euclidean plane, so I added more. So it would take longer for me to get around this than if this was a non-Euclidean, or no, Euclidean plane, a flat plane, but this is not what we consider normal. But I wonder, what do you think? You may be thinking, where do we live then? You know, like, how does this fit into us? We do not live in a Euclidean plane. Or do we? It's debatable, but our world, Earth, is non-Euclidean. It is concave? I forgot. But do you know the way how the world is 100% flat? I mean, not 100% flat, it is a circular thing. It is, our world is circular. So technically, if we drew two parallel lines, they would actually meet. So parallel lines are the only, in a Euclidean plane, parallel lines would be the only place where the parallel lines would not go like this or like this. So right here, if two parallel lines were drawn, they would go like this, you know, instead of going straight in a Euclidean world. And if on Earth, if you put on here, this is Earth, if you put two of them here, they would meet. And you can actually see this, for example, if you drew a big triangle on Earth, all the degrees, all of the edges would be 90 degrees. So 90 degrees, 90 degrees, 90 degrees, and yeah. So if you can make a triangle out of 90 degrees and put it on Earth. That's pretty cool. And here you can do the opposite. Triangles on here would be less than 90 degrees. Or no, less than 60 degrees. Equilateral triangles. So that's cool. And yeah. And if we lived on a hyperbolic plane of existence, then it would be a very long existence of walking. You'd have to walk a lot, because in a Euclidean plane, right, if you walk here, it would take the same distance to walk here or here, but, you know, it's all the same. But it would take a lot longer to walk from here. And a strange thing as well, even when you're walking straight on a non-Euclidean plane, you can sometimes turn accidentally without manually trying to turn. For what I mean is, if you walk, right, I'm gonna try and show you. If you walk here, now you're 45 degrees, like that, like that. Now you're back to normal. So that, like that, 90 degrees. So, I mean 45. So basically, you turn when you walk straight. But what is walking straight? We think of walking straight in Euclidean terms. Whenever you walk straight, you walk like this, yeah? But on a non-Euclidean plane, especially a hyperbolic plane, walking straight, as seen with the parallel lines, to walk straight you'd have to go like this. So you'd have to turn to walk straight. What? That is crazy, man. So, yeah, those are some of the cool things about non-Euclidean planes. So yeah, if you want, you can knit one. They look pretty cool, to be honest. And if you want, you can send it to me. Send it to me, please. If you make one. Especially for me. Because if you don't send it, then I won't get it. That's your choice, dear viewer. Dear viewers. if anyone just watching this. Anyway, goodbye.